Okay, you guys, so I went ahead and I took my project, my JEST game engine from the JavaScript, and I ported it over into C++. So this is the C++ version. There's probably a lot of commented code that needs to be removed. Um, this looks pretty clean though. I think I cleaned it up. And anyways, it's way better than it was the last time I had showed the preview of it. Anyways, I'm thinking of releasing this for the first time, so this would be open source, and it's going to be, I guess, version 0.1 or 0.2. I'm not sure what number I'd slap on it. I haven't really released the C++ version yet, so let's just go with 0.1. You can go ahead and just see what I have going for it already. So if I pull up my terminal here, I've already compiled it with Ninja. And so this is working on Mac. And you can see it is now booting up the application. And you can see what's going on in the background. It was attempting to connect to the server, but I don't have the server open right now. So it fails gracefully and continues into the application. And then what opens up here is this generic GUI. I have the start of a GUI system going, a graphical user interface that you can start implementing, like advanced menus and things like that. And so this is all custom coded. It's not using anyone's framework for that. So it could probably be improved upon. But anyways, it's still slightly working. You can see that there is this scroll bar going with these generic terms and conditions. And you click accept, and it pulls you into the game. And so this is all done in C++. And you can see this is replicating Graal. You've got on-wall detection. And if you come up here, you can actually use this chat bar and just say something like, this is, or how about this, moon dash in your weak soul. And so you can see that it gets logged down here in the terminal, and then it gets set as text above the player. Now, ideally, it would be a better font and it would look better, but this is just thrown together in order to get something working, which is a generic working prototype. And so you can see this has the overmap working. It's loading the levels. It's loading the sprites. It's running the animations. You can slash your sword. You can run around. This actually does connect to the server, and it does pull in a separate character. So this is actually supposed to be, this little separate character you see here is supposed to be connected to the server. I just haven't put too much work into that just yet because it's still under construction. So this is version 0.1 of the game engine. And you can see it's working quite well. It is coded very nicely. Most of the work that I put into the engine, for one, was going into getting it into a place where people could use it for themselves. So rather than trying to create a full functioning title and then allowing people to like run a server on that platform as a third party plugin, I would rather have a game engine that's built from the ground up that is made for the developers. And so that's what's happening here, is this was made for the developers. And so the reason why there's these little white things there is, you know, this is just an old tile set and this is a newer level, so those tiles don't exist in the older tile set. But it's not a bug. There's nothing going on there. So yeah, like everything's working really good. I want to go ahead and show you the back end of this because this is going open source. So yeah, this is, I'll just shut that down. If you come into the code here, like I said, I've put more emphasis on developing this for the developers. So this is a mirrored version of the JavaScript game engine that I just released, which is now on version 0.2. And so that is also open source. I would check that out if you haven't yet. It's the video before this one. And this here is the C++ mirror, quote unquote, mirror of it. So it's supposed to function very, very, very similar, if not almost identical. But obviously, since it's in C++, it's different. But it does have a lot of the same folder structures and methodologies. So if you're switching from the JavaScript to the C++ as a developer and you want to manage both code bases of your game, you can do that, and it's not going to be the biggest chore in the world. So the idea is to have the JavaScript version, so you can have that Electron plugin and you can have that browser version of your game functioning, and you can have it so that it can be like this Discord type game, because Discord, I believe, is running on Electron. And the same thing with C++, it's now a mirrored version of it. You can have that standalone app that is coded in C++ in a way that is much more secure and optimized, closer to the system and hardware than JavaScript. And also, you can port that into other different platforms where JavaScript might not be as portable. And so anyways, this is supposed to be basically a functioning quote-unquote mirror, but it is different, and in my opinion, it's better because it's the C++ version. So anyway, if you look into this sidebar here, this is the C game folder that I have on my JEST desktop. And if you're looking at the utilities here, there's something for handling the output gracefully, so that you can kind of separate output in the console during asynchronous behaviors. And the same thing with this task queue here. This also helps to facilitate different tasks so it can better integrate with asynchronous activity. So the task queue is going to allow you to essentially synchronize, tasks, one after another, and you can run those from the main thread in your application, so that you don't have to have it, getting into these very obviously serious race conditions. And so the task queue is part of just the overall utilities folder. There's a transfer folder, which is going to have that data folder where the transmission is. So if you've seen in the JavaScript version, there's a folder called transmission and inquiry, and this is going to allow you to make web calls to download data. So you've got the inquiry, which is the data that you are setting up to inquire about. And so you create this inquiry object, and then you pass it through a transmission, and the transmission sends it through curl. So this is using curl. Now, one thing you can't really do with C++ is get away without using libraries. Like in JavaScript, you don't really need external libraries because you can just create your own libraries. That's because JavaScript is already implementing a bunch of C++ libraries in the back end. That's just the way that it comes wrapped. So JavaScript is super useful because it already comes prepackaged with tons of libraries underneath the JavaScript compile code. And so anyways, because JavaScript's not really compiled, it's just compiled internally. And internally, JavaScript is using tons of libraries because these are written in different languages and converted into binaries. And so you can put them into your project. And so anyway, there is a bunch of libraries that this does require, and here's a bunch of them. I'm not sure that I'm even using all of them anymore. Like, I'm not using SDL3, I'm pretty sure. And I think I got rid of WebSockets. I think I got rid of that one. Or maybe I got rid of IX WebSocket. I'm not sure. We'll take a look in a second here. But there's a bunch of different libraries that you're going to want and that you're going to need to get this project running. So those are very important, but, cut to the chase here. The transmission is relying upon, some of these different plugins and stuff, and the ultimate goal is to grab the curl. And so if you can call a curl request, you can definitely just basically connect to an HTTP request and, send it your header data, and it'll send back the information that you're requesting. Quote unquote, let's just put it in idiot's terms, you're downloading data or you're downloading, web files. So the transmission is going to allow you to connect to a server, not a WebSocket live server, but a remote server to download data. And so that's what the transmission's for. But in order for the transmission to know what to do, it needs your inquiry. So the inquiry object is going to set up the different information that you're looking for. So that's, referring to the type of information you're sending to it, the type of data, the data type that you expect in return, whether it's going to be, text or JSON or blob data or whatever it is. So there's different types of, settings that you're going to pass to this HTTP request, and the inquiry is going to have all of that in there. So, you're going to pass this address, whether it's the network is typically always going to be remote. I just stuck that in there because it's kind of standardized in my software. And so address and network are kind of just the two standard things that come together. And then you're talking about the method. So whether you are calling a post or a get, request. So if you want to post to a web HTTP address, you can post to it. If you're just, calling a get, you can do that. The action type that the inquiry is going to be, basically it's just going to be load typically. But, the context, and this is just an extra variable. So you say, hey, I'm looking for settings. So your action and your context are basically custom settings. It's just two generic variables that a lot of different HTTP requests might require. And so it's highly optional, but it's still required. It's just optional whether or not you use it. So let's say your HTTP request wants to know what action is being taken and what the context about that action is. You just have these two default variables. So let's say, for example, my action was supposed to be grab directory info. And then the context was in, only files rather than, including URLs. So yeah, like do you see what I'm saying? I know I'm just throwing that out there. So then your HTTP request, you would then interpret that and say, oh, they're asking to grab the directory. And then the context of what they're doing at that directory is they just want a list of the files. So these are just two very convenient things that I stuck there because most HTTP requests, in my experience, in my many decades of programming, takes about an action and a context variable at the most in order to understand what the user's doing. You can add more data to that if you wanted to. So I think that's what this was, is you can add more data to it. The response type that you're looking for, the request type, and then the headers. So your inquiry object here is going to calibrate what this transmission curl request is going to actually encompass and what it's going to fucking do. Moving on from this transfer folder, you can look that through. There is the system folder, and then in here we have like this default application class. I'm not sure that I'm actually using this. I might be. This is something I was planning to use. So basically every application would essentially, inherit from this. Let me see if it does. See, I'm not sure that these do. But ideally in the future they would. Yeah, no, they don't. No, but ideally in the future, all, your application would extend from this, system application class so that you can kind of systemize what you're doing with the game engine. But this is just a placeholder for now. Like I said, this is all beta mode. So anyways, we just have this kind of global enumerators header file that you can include, your environment, and then, your SDL includes, and this right here is the window. So this is going to be attached to SDL. So this is using SDL2, and SDL2 is going to allow you to open up an operating system window. So like a Macintosh window, right? You see this up here with like the Macintosh window. It comes with this draggable header, and it's got the maximize, the minimize button, and close button. Minimize. Yeah. So, anyways, that is handled through SDL. SDL2 has the library to just open up an operating system window. And so this is the wrapper for the SDL window. And so this right here is the class for it. And it comes with a number of stuff like the default width and height, the title of the window, and then some different methods that you can use, like set the title, resize it, clear the window drawing, present whatever is in the buffer for the window drawing to be displayed, and then just get width and get height. So this is just a wrapper for the SDL window. And again, that's the SDL2 window. So if you go into Media Core here, you can see that it's got your core timeout method. So this is the timer. And this is actually really useful. This is, how do I want to put this? It's like a higher end design timeout system that is not based upon system. What's the term I'm looking for? System lag. It's not like it bypasses system lag, and the way that it's doing that is it's using this ticker logic. And so the tick function, essentially what it does is, while this is running at a certain FPS, the ticker class is, well, the timeout class, it's using the tick logic, the ticker clock inside of this is calibrated so that even though it's running at a specified FPS, your system experiences different lags and stuff, but there is an internal system clock that is based upon like a consistent, what is it called? It's not called the platonic clock or something like that. I forget the term for it. But anyway, what it's doing is it's using that internal system clock to ensure that if the system processing is slowed down and the frame rate is not up to speed, it'll take all of the missed iteration ticks by comparing, the system performance to the internal atomic clock and not platonic. Did I say platonic earlier? The atomic clock. Yeah, so it'll take the atomic clock and compare the time that was missed and compare how many ticks have been missed. And it'll just run a for loop and just say, okay, let's, quickly compensate for all of those missed ticks, those missed, iterations in the central loop. And so it compensates for system lag using the atomic clock. And then with that, there's different events that you can plug into, like the pre-process, the emit, where it's processed, and then when it's rendered finally. So you can get different information from your timeout class. This is very, very crucial for game design and game logic specifically, or just, anything that has, a lot of visual components to it. So the timeout class is very, very useful. And this is where your central loop within your application is going to be run. I think I'm running 3 of these, two or 3 of them. And I'll show you those in a second. So there's about 2 or 3 of these that I'm running in order to keep the game running. And we'll look at those in a minute. But the timeout class is very important for you to understand. This is where your central loop is going to work. And again, it's using this atomic clock to compare the missed iterations in your timeout, loop, so that you don't miss ticks, and then it'll just run them and compensate for them so that you are constantly running on what appears to be a consistent FPS. In this elements folder here, we have different things that you might use for media, because again, this is the media core. So these are media elements. So if you have like a text object, one thing that C++ doesn't come with that JavaScript does is text. C++ doesn't come with anything, basically. other than its internal, code base or compiler base. And so this is, I think, using C++ 17. I'm on C++ 17, which I consider to be pretty reliable and pretty modern. And so I wanted to go with something that wasn't too fresh, that it would, push a lot of options out and make a lot of tools incompatible and unusable. But I also didn't want to go with an older version of C++ that would just be completely pointless. So I'm running on about, I think, C++ 17, and the text, again, does not come prepackaged inside of C++. So the way that text works is you have to have a library for it or create your own library for it where you are rendering the vectors of your fonts itself. So I have this asset folder here, and I'm just using Kingsbridge, which is by, what's his name? Ray Larobi, I think is his name. And he is, I wonder if I can find his name in here real quick. But anyway, I knew him from years ago. He's a very famous font developer. So back in the late 90s, I actually reached out to him while I was making Graal. And I asked him to create a medieval font. And he came back and created something called Trollbait, just as an inspiration from my request. And so I guess Trollbait is also now public domain, but he's a very, very talented font designer, and he's the author of Kingsbridge. And so this is also now open source. And I spoke to him in an email, and he's like, hey, bro, he's like, yeah, I remember the Trollbait font. He's like, I have a bunch of other fonts too, and they're also public domain. He's like, so feel free to pick one. And so I just went through the list of them. And so I don't really like Kingsbridge. I just like the name of it. I think it's a little bit, I don't know. I just don't know if it works with the design. But there is, Kingsbridge is in here. It is from a public domain font list. And so if you're looking in Elements here, that vector data for that font has to be rendered somehow. And so what happens is I just fall back here on SDL's TrueType font library, which allows you to render that font vector data in different ways. And so I created this wrapper class for it called text that comes with various options. You can do different frames and a layout, whether the alignment is going to be, you can do the outline size if you want to have outlines, you can have a shadow, you can decide the color, the outline color, the font size, whether things are going to wrap or not, and all this different stuff. You can set your font, you can attach it to a specific window. And so there's a lot of different things going on here within this wrapper class that is utilizing SDL TrueType font library. And so this is very, very, pivotal if you want to render fonts in your game. So this is part of the media core folder, and I do actually have a user interface include now that is part of the game engine itself, that's also a little bit higher level and that handles the graphical user interface. And so that is also implementing the text node class that I have here from the media core folder. But here, I'll just show it to you. So you can see that there's a text node for the user interface. So there's a wrapper of a wrapper. There's a whole user interface system where you have images, a screen, your text area, your text field, whether or not text is going to be selectable or not, a user interface image, buttons, stuff like that. So this is also utilizing that wrapper class, which itself is using SDL's TrueType font. And that is a library include from the libraries folder down here. So if you look down here, you can see STL2 TrueType font. And down in the media folder, moving along here, you can see that there is a wrapper for images. So you've got your image wrapper class, and this is using a window. So it's like attached to a window, and you can render images. And so this stores image data. And then you have this canvas here, which actually renders that data and stores it on a canvas. And so you have these canvases that are inheriting from image class, just like it does in the JavaScript game engine, the JEST game engine of JavaScript. And these are handling a window object, and that window object is attached to the SDL window, which is the operating system window. So you can, render images through the textures and push them into the screen and all that jazz. So if you go into this little generic class here, this is just for like generic files. This is for audio objects. If you want to place, audio, there is an audio wrapper class. And audio wrapper class is, let's see, what's that using? Doctor, yeah, DR. And so if you go down into the library down here, I forget what DR was. What was the root for that? I don't think it was Osseo, was it? Was it Osseo? It might be Osseo. Or Macron. It's Macron. Yeah, it is Macron. So Macron created the Doctor library so you can handle WAV files and MP3s. And so that is going to be your wrapper class for that Macron Doctor library for MP3 and WAV files. This is your audio class inside of Media Core element. And then we have like this thing for albums. This is just kind of like a generic thing. I'm not going to go into that right now. But then we also have context. So things that are being anchored allows you to kind of trace its coordinates and its dimensions and set various attributes about this, anchor. So a lot of objects have an internal anchor, and they just, inherit from anchor, or they're implementing an anchor as a property. So anchor is very important, but it's very much just like a generic object that allows you to manipulate coordinates and dimensions. And then if you go into audio in here, this is just has like your includes. So this is where the Doctor includes are being, implemented as a CPP file. And then if you go into animation here, this is where the GANI file, the GANI file system that you see in Graal, I already have this in JavaScript, and this is the C++ version of it. And so what that does is it breaks down the GANI animations into these different parts. So you have the animation itself, and the animation itself has frames, and the frames have layers, and then the layers have sprites. Well, actually, I think the layers have stickers, and stickers are references to sprites. And then you have these views, and the view itself is just a calibration of an animation. So what it is, it's kind of like an anchor class where it's just a portable information object that has different data about the animation itself. So the view object allows you to plug into an animation object, and instead of having, multiple of the same animation object, which is just going to use up a bunch of, memory, and it's going to be a hassle to try to modify animations, GANI files globally, you can have different views of them. So like if I wanted, 10 players to be sharing the same animation object, but using, they're viewing it from different frames, and they're viewing it with different colors and different sprites and images, then the view is going to allow you to do that. So the view allows you to calibrate the same animation object and view it from different angles, quote unquote. This is the, interface thing, which has different parsing methods inside of it. So the data, again, here we have that data folder with the server. So this plugs into a WebSocket library, and this is using WebSocket PP. So I believe I was using, one of them was not good, and it's not WebSocket PP, it was the other one. And one of them had like this memory leak in it. I just got tired of it and I just switched over to this. So WebSocket PP has been pretty good. And this is implementing that. That's part of the library. And this is also implementing, nlomen's JSON class, which, everybody needs JSON. You can't really get by without JSON unless you want to waste your time. So JSON's such a great quote unquote data type. And nlomen, this is a library include also. So this is in your libraries. This is created by nlomen. I don't know if that's Neil Loman. I'm not sure what it stands for, but it's nlomen. And the JSON data type is being heavily used between different WebSocket calls to and from the server. So you have a lot of WebSocket information going on there that is very JSON oriented. If you go into these base classes, you can see that there is an event target, something that's configurable, things that have callbacks, something that has object properties and things. Some of this stuff I might not even be using, like apply hooks. I don't think I'm even using these. But, these are the base inheritance parent classes that a lot of these things are using. So that's that for, the overarching umbrella of the engine itself. But the internal engine itself is stored, again, inside of this JEST apps folder here. So if you go into JEST, apps, JEST, we're now into this application of the game itself. So the core of this is going to be, again, the JEST class here. And you can see I put some word text here. And this is where a lot of stuff is getting imported or included or forward declared and things like that. And so this is going to be the heart of the application. And inside of this, there's going to be all these methods that launch the application and set it up. I believe the core central timeout loop that I was talking about is being handled inside of this class. So you can shift gears and change the application into different modes that are going to allow it to launch or shut down or things like that. And this central drive method here, you can see it handles logic based upon the current application, gear, whatever the gear that it's in. And so let's say it's in the loading sequence, it'll handle that from this, and there's nothing really happening in the loading sequence, so it just automatically shifts into inactive. But I stuck that there in case you wanted to preload stuff. You could do that through a loading gear. And then it shifts it into this inactive state. And there's not really anything happening in the inactive state either right now, because this is beta mode, so the game engine doesn't really go into inactive state, so it automatically just launches. And so anyways, some of these could be renamed better, but this is just trying to get some type of sequence going for your game engine, so it's not just like, oh, I have one state, what do I do with it? You have a bunch of different gears that you can push your application into, and you can handle different, aspects or settings or screens for that based upon the gear that the application is in. So if you go into here where it's saying that the application is in launch mode, it starts to launch the application. So you can see it launches the application or it throws an error, and then it flips it into running mode if it succeeds. So if we don't get this error, it'll just continue and it'll flip the application into running mode after it launches. So it launches and now it's running. And when it's running, this is where that timeout ticker loop begins. So I have one for SDL, and this is the central ticker for SDL, events and logic, where you're trying to update your windows and stuff like that and render and push the latest rendering of image data and textures into the screen. And the same thing with this right here. This is just running it, and then we have a ticker for the drive itself, and this is the application driver loop, where it's just kind of the central ticker for the application itself, and that's supposed to be separated from the SDL events. And so anyways, we're also letting the system breathe a little bit, because sometimes what happens is if the application is so fast, the operating system itself will it'll actually refresh your window faster than the SDL can process, and then you'll get like these flickers in the window. And so we just kind of add like this little, SDL delay just to let the system breathe a little bit so that we're not getting those flickers and glitches. It's almost like if you've ever filmed a TV with a camera and the frame rate of the recorder is faster than the refresh rate of the TV, then you can see the scan lines of the TV like moving. So that's kind of a similar thing what's happening with SDL, because SDL is plugging into the operating system. It's just a library. So sometimes the window itself in SDL is actually not rendering fast enough. And so you just kind of give it a little SDL delay and let it breathe a little bit so that you can kind of step back and avoid, the system refreshing and clearing the window faster than it's rendering. And it'll make, the image not flicker and stuff like that. So anyways, this, has different things in here for like setting up the audio. There is a component in here for audio itself, and that is the soundboard. And then you also have the mixer. So you can play sounds, and you can also use a mixer. And the mixer allows you to play sounds simultaneously without needing to play them on different what's the term I'm thinking of? Sorry, I have a million things going on in my head. Anyways, you know what I'm talking about. Without playing them on, what is that term? Let me just look it up. Hold on. Device? I think it's on different devices. And so anyways, the mixer allows you to play them all through one sequence. So rather than having to open up multiple devices or whatever, you can have, I don't think that's the right term. Anyway, whatever. The mixer allows you to play them through one continuous stream so that you don't have, because there's a limit. I believe it's, it is device. So there's a limit. I think you get like 16 devices by maximum by default inside of SDL's audio. And so what that does is, instead of trying to play a bunch of sounds on a new device every time, which you could do, but that's really stupid. Don't ever do that. You can use a single mixer that plays all of the sounds and streams them into the same buffer, and then it'll play them in sequence at their proper time, and it's all being played on one single audio device. And so the mixer is really just a way to bypass having to open up multiple audio devices to play one sound. Inside of the file here, we have the secretary, that transmitter and the file loader that I showed in the JavaScript version. This allows you to load multiple files, single files, and a bunch of different classes extend file loader. So like if I wanted to, again, do things with my Janny files, I've got my Fantascope here that is inheriting from file loader, and that makes my Fantascope a breeze to create. I can basically just inherit it, tell it the file types, and then tell it the different file instance types that is supposed to represent my wrapped Janny objects. And I can, throw my validate record method in there and the create object method in there so that I can just quickly take data that's been parsed after it's been downloaded or read from the hard drive, and I can wrap it and turn it into an object. And that's going to be a functioning Janny file as it works inside of the game engine itself. So I'm not going to go into that too much because I've already done it in the other video. And it works very similar in C++, the same way it does in JavaScript. If you haven't seen the other video, I guess go watch it. But some of this stuff is pretty straightforward, especially if you're a programmer. I know it's not like easy and it takes time to figure out, but like I don't want to overload this video with tons of information. But anyway, so the GUI here, there's like a display object, just a GUI element. But most of that UI stuff is happening inside of here. And so all of the UI elements that you saw, like when the game loaded up that had the terms and conditions, that text field where I entered text while the player was walking around and he could talk, these are part of my UI system. This is a whole library that I created called the user interface. And so the user interface is basically trying to replicate JavaScript in a way. I I know that sounds crazy, but it's true. So what I wanted to do was, because C++ isn't JavaScript, there's a lot of handy things inside of JavaScript that I thought were super fucking dope. And so I wanted to create a way for you to actually create your user interface using CSS and HTML. So what I ended up doing was I wrote this whole user interface library that is parsing CSS to an extent. And some of what that's doing is, if you go into the Play application up here, there's an interface for it. And this interface, you can see that it's actually, what it's doing is it's using CSS to create my menu user face. So you don't have to sit around and fuck with 100 fucking objects and set them up manually. And every time you need to change something, you have to go through and change 500 things. You can actually handle your user interface using CSS, and it gets processed and turned into a user interface C++ system. So it'll set that up for you, and it'll take this CSS and style it for you so you can make your global changes and tweak things and tweak your interface. It's super fucking useful, man. But the user interface is basically, it's a step toward kind of replicating CSS and JavaScript interface, HTML development inside of our library. And then you've got your other, different things here. Here's that online wrapper that implements the WebSockets. Here is your levels, your overworld, the Janny parser. Ideally, I guess the parser should all be in the same folder. I don't know. But there's not really anything else in the Janny folder right now because most of that's being implemented inside the animation thing. It's the same folder. So, inside of, let's see here, Play, this is where like the player and the user are, the guest user. So yeah, I would go ahead and, if you're interested and you want a nice code base to get your game engine going, go ahead and do that. So, one important thing is that the secretary is running, various threads. This is thread safe, so it's downloading files kind of in the background there. And what it does then, too, is it allows you to throw some of that data based upon what you send through your request. You can actually have that, like, sent through, what am I thinking of? Let me see. There's a number of options. Let me find one starting point, and we'll tackle that. So you can delegate the task to the main thread, or you can run it as is, I believe. This was a recent change that I made to it. But anyway, the point is that, like, you don't want to... It's a long story, man. I'm not even going to talk about it. Like, it's so complicated. Like, if you guys understand how threads work and mutexes work and, race conditions, I don't even know where to begin in this video with that. It's just like you have to know, like, especially during the startup and then when the application's running itself, there's just so many different race conditions and stuff. So a lot of times you can take that data and you can throw it back to the main thread, which it was using that thing I was talking about earlier. Where is that? not system, it was utilities, task queue. So a lot of them will use like this task queue, and the task queue gets pulled into the main thread and run every iteration. And so instead of having certain things being set up inside of the asynchronous, thread, the separate thread, it will throw some of these finalized tasks during like downloads and parsing things back into the main thread through that task queue. So just really look through this and you can figure out what I'm doing. You can see where that's getting defined too. Let me see here. So inside of the main JEST application CPP file, you can see that I have this stuff set up here. So right here, it is where I'm defining my different types of files. So I accept, PNGs, and this is being deleted. I'm not using this anymore. And that was using the gallery. At one point, I was using that gallery. I deprecated that in C++ as well, so that's out the window. So the PNGs are super simple now too. That's being handled with blob data. And then it calls this callback to parse the PNG file. So I believe NQ means that this goes back to the main thread. Again, this is a new thing that I've added. Certain things don't need to be on the main thread, but in order for it to be safe, some of them do need to be on the main thread. And so I believe it was JSON that is not. It does not need to be on the main thread because you can just handle that and just be one and done and move on with it. But a lot of these, I didn't want there to be conflicts, for race conditions and stuff, and that would obviously trash your memory and crash the application. So you can specify whether or not you want it to be delegated back to the main thread task queue when it finishes. And so that's when it gets parsed. I believe this gets run through on the main thread, and so it's finished safely. So it's downloading asynchronously in the background, and it's parsing on the main thread once it's finished, and then setting that information up safely. So these are, where you're going to define your file types. So you got, your tile defs, your NW level file, the JANI, which is, the same thing as a GANI. It's right now I'm renaming it to JANI because I plan to customize the way that data is parsed and the way that file is read, but I just haven't got around to it. So I just, JANI is GANI for all intents and purposes, just so you know. Let me just type that out. For now, and that plans to change. And then there's your MP3 and your WAV file types and all that stuff. So this is being registered inside the secretary, and then the secretary handles that data and downloads it. And the secretary is basically what it's doing is it's using these inquiries that I showed you inside of the transfer folder here. Was it? Yeah, inside of data transfer, you got inquiry, and then you've got transmission. So the secretary is using transmissions and it's creating inquiries, and it's downloading data, and you can also read data locally. So we got local transport, which allows you to read data locally. So this will pull stuff from the system itself, and if you go into, again, this file loader class here. The file loader class itself is an interface for the secretary, which is super, super useful. So the file loader class, what this does is it allows you to wrap different file types and automate the way that they're downloaded and handled. So the secretary might download, the data and parse it, but if you want that parsed data to be turned into a game object, what you want then is a specific class that inherits from file loader. And so file loader interacts with the secretary, downloads that data. That data is then parsed, via the secretary, because you tell it how to the secretary is to parse that file type. And then, the Fantascope, for example, here is a file loader object. So the file loader here, my Fantascope allows me to register and just request to download a specific address, and it must be of a JANI file type. That's the only type that it accepts. So the Fantascope will call the secretary, download Janny files, and then they get created in here. So that parsed data, when that Janny file gets parsed, what it gets parsed into is it actually gets parsed into an animation. So my Janny parser in the secretary actually parses it into that media core animation object that I was talking about. So these are system animations. It's not really a Ganny. These are actually system animations. But this allows, the Fantascope allows us to, and the Janny parser allows us to turn Ganny files into JEST animation objects. And so these are, system animations, but if you want to turn a Ganny into a system animation, the secretary will do that via the Janny parser. And the way that works is that the secretary automatically does that. And I've already shown you that. So if you look in here, I put inside of Janny as a data type for secretary. When I register that data type, I said that I want it to call this parse Janny file after that data is finished downloading. So it's going to download it as raw text. It can only download those files from the Janny's folder. And then you can see here that it is parsing it as a Janny file. And so what that method looks like is, and this is just going to show you just a quick idea of how this works, and and this will get you going. So if you look into what parse Janny does, is it just validates the data. It's just a lot of like validation stuff. Make sure that we've got valid data. It's valid vector char data, and then it goes into my Janny parser object and it passes the downloaded text to it, and also the file stem name. So let's say my Ganny file was walk.ganny, right? In my application, we're renaming Gannys to Janny just for now. So, but just so you guys understand, the stem of walk.ganny is walk. So the request will, pass to the Janny parser and tell it that it is the walk animation. And then it passed that downloaded data from the walk animation Ganny file into the parser. And it parses it into a system animation object. And what happens then is that's stored inside of the secretary and filed away as a system animation. So this is what triggered it. My Fantascope called it to download. You called the secretary to download that, and the secretary automatically parses it into a system animation object. So then when I go to create my file object, what it has is an animation. And you can see that here. So that Annie, data, the animation data, which you can see it's a shared pointer to an animation object, it validates it, casts it back into an animation shared shared pointer, and then through here, it sets up my Janny game object, tells it what the file address is, sets up the Janny game object, and tells it the animation object that was created, and stores it inside of the Janny wrapper. So now I have this whole, game animation that includes information about it, that is interacting with the game engine itself. It's part of the application, and it's storing that parse data that was already in the back end parsed into a system animation, and it's storing that animation data, and I have access to it inside of my Janny game object. So it's really just an easy way to interface with the secretary and wrap the parsed data into game objects is the whole point of that file loader. I know I said it in the other video, but I'm saying it again. So anyway, yeah, and I would go ahead and check this out. And so this is going to be available for, open source. Again, credit me, share it around, be nice, use it to your advantage. If you're expanding upon it, please fork it and include plugins for other users inside of the project so that we can all continue to grow together. And if you wanted to use it for commercial licenses or whatever, right now I'm not like a massive stickler on it, but please contact me. If your project becomes big and you're now making money on it, I'm happy to work out a deal with you so that you can, use my code base and it's not going to cost you fucking insane amounts of money. It'll just be like, I just want a little bit of royalties. That's all. But this is going to get your fucking game started. This is an insane project. This has taken, a lot of work. It's taken me decades of experience to get here. And so, when Stefan and Unix Matt stole my games and stuff, like the biggest thing that was holding me back was I was always a visionary, an artist, a writer, a poet. I was very much into music and just like composing worlds and ideas and concepts and putting them together in marketing. But I wasn't good at programming a whole game engine from the back end. So that's how they got away with it. But I have spent a long time learning and getting to where I am. So anyways, I was able to finally get this game engine created in JavaScript and in C++. And so this is a good starting point. I would, if I was you, get plugged into my Discord server, check out the description below, find the download link in the description below, go to my message board, register an account if you haven't already. It's mongers.net. And there's a thread there that you can download it and check out the JavaScript JEST game engine version 0.2 if you haven't already. And go ahead and get going. And please, again, let people know about it. Share the project, share the information, and let us know what you're up to.